este episodio nos acompaña Uri Shaked, es cofundador de simulador en línea de sistemas embebidos Wokwi. Además está trabajando en el proyecto de Tiny Tapeout, que promete hacer la fabricación del ASIC personalizada y el diseño digital sean más accesibles que nunca. Uri ha sido experto en desarrollo de Google por tecnologías, un referente del mundo web y un apasionado creador en el ámbito maker. Además se considera un entusiasta de la salsa y aprender español. Acompáñame a conocer su historia, cómo inició, por qué creó Wokwi y qué es la Salsa Beat Machine. Comencemos.
Gracias. I'm fine. So I told Wels that I understand Spanish and yo puedo hablar, pero it's easier when talking about technical stuff. It's easier for me to speak English just because I never remember if a resistor is a resistencia or resistador or whatever. So I will mix and match as we go.
This episode is going to be maybe sometimes in English and sometimes in Spanish. Spanglish, yeah? You're right. But it will be good. ¿Cómo inicias en el mundo de la tecnología? How do you start in the technology?
In the technology world. Yeah, that was a long time ago. I remember, I think it was for my 6 or 7 years old birthday when my presents were a personal computer that was, I think, 8086, the old one, and also a Monopoly game. And I played a Monopoly game, and I'm like, there is a boring machine in my room. I will check it out later. I don't know. The game is much more interesting for a 6 years old. And then, I don't know, I saw my father playing with that machine, and he started playing some games, and it was, oh, this machine can actually be interesting. So I started playing games, and I think for 2 years I just had this machine and played games. But then 2 years later it broke. It didn't boot anymore. So one of my family members bought me a book about how to repair computers and MS-DOS and all of that stuff. Mm-hmm. And at the end of the book, they add a chapter about QBasic, introduction to programming. So that's how I started programming. I just picked up the book and started like, oh, I can actually make my own games and tell the computer what to do. So this is sort of how I started. And then in elementary school, we also had like a weekly session about electronics, like a weekly class about electronics. Mm-hmm. So that's how I learned the basics of like resistors, LEDs, not really. We didn't use microcontrollers, just five timers and that kind of stuff.
Yeah, your focus was in web design, but then you changed, no? Or how it started?
Yeah, so in the early days, I was just writing a lot of code in C++, Turbo Pascal. But when the web started, I learned JavaScript, and I figured out it's easier to develop software and share them with others if I put them on the web. So I started with an old language called TCL, which... interestingly, I still use now because of the chip and the ASIC stuff.
Yeah.
Probably many of the listeners never heard of it. And then I moved to Python, and then JavaScript became popular. So I started doing JavaScript and building larger web applications. So photo galleries, forum systems, whatnot. And I don't know, I just love to create, and the web is a combination of very fast cycles. You just write something and you see the result. And it's also very visual on one hand, but on the other hand, there is potentially a lot of backend behind. So you can build really large applications and have like the visual part iterate really quickly, not like traditional software development where you make changes, then you need to send a file to the customers, they need to install it. In the web, you just nowadays you just make a change and it's live immediately.
Yeah.
So I find it kind of magical, these quick
Yeah.
cycles and mass distribution of apps.
Ese fue el inicio de entrar al mundo maker.
When I started with the electronic course back in elementary school, it was fun, but I left it there. Like the course ended and I didn't do anything for a few years. But then at some point, some friends started doing some building stuff with microcontrollers. And I think at that point I realized, hey, this skill of writing software is not just for programming web pages and making applications. It can go beyond the screen, beyond the computer. You can start writing code that controls things in the real world. And I think my first electronics project was I made my own PCB using this acid ferrichloride that was very much like Arduino. It has like a USB port, and you could use the USB to upload new code to the microcontroller. And I broke out a few of the microcontroller pins. So I made sort of my own development board just because I was so excited about the possibilities of programming the world.
Yeah.
So I wanted to have like kind of platform I could use for experiments. And then the actual first project that I made using that platform was persistence of vision. So when you have a few LEDs and LEDs and you move them fast, I took an old hard drive. I removed all the parts, just left the spindle, the motor that spins in the hard drive. And then I attached to it a strip of LEDs and wrote some code on the microcontroller to synchronize them. So when you run it, it would say hello. And I spent like a few months programming that, and that's a stepper motor for the hard drive. So it's not just like DC motor when you give it current. I actually had to write some kind of algorithm that would gradually spin it up until it went to the speed that I wanted, and fine tune it. And it's not like today when you have you click on a button and the firmware goes magically to your dev board. Back then I had like, I don't know if you remember, but computers had this like parallel port with many pins. So I made an adapter that you could use the parallel port as a programmer for the microcontroller. And that would take a lot of time because the programming would be done through a Python script that just bit-banged the firmware to the microcontroller. So I spent a lot of time just, fiddling with microcontrollers and trying to optimize my workflow and basically making. I didn't know I was making back then.
No, you didn't know?
I think making is like a new word. I think it's like 5 or 10 years that people are making. Back then I was just doing fun with electronics. I didn't know what it was called.
But also you're working with open source projects, yeah? That is something like Maker, no? It's open source. Can you explain how influence this to make open source to your life, to your career?
I think open source is a very interesting thing because it's, first of all, the way I was introduced to this world of open source is through web development. In web development, open source is very common. Most of the libraries and the packages and the ecosystem is open. It's not even as like traditional open source. At least in my experience, there is like the Eclipse IDE, which is open source, right? But I never went to look at the source code of Eclipse IDE. Or Firefox is open source web browser, right? But I never went to look into the sources of Firefox, maybe just once in my life. But for web development, it was very accessible open source because the projects are many of the projects are small, and there is a lot of community on GitHub around those projects. So it's much easier, to navigate a small open source library that you are using and learn what they did there and maybe contribute some improvements or fix some bugs, rather than those traditional heavyweight open source projects like Linux, Firefox, or Eclipse, where you had like millions of lines of code, and just setting up the dev environment is like a few days of work. So I think for me, like, the web was what got me into open source, and it's sort of the standard way of doing things on the web. Like, you make a library, you don't sell it, you just open source it and make it available to others. And that's where I got my current, or that's when I got into open source, when just sharing some code that I wrote with other people, so they can use it and potentially improve it. And I think that's one of the things that got me into this Google program, the Google Developer Experts program. They noticed that I'm doing a lot of open source related to the Angular framework. That was a web development framework that I used for some of my older apps. And they were like, okay, we have this new program where people who are active in the open source community around Angular can join and get our support. So I joined, and I became connected with Google this way. So I think that's one of the first benefits that I got out of my involvement with open source and this online community.
Uno de tus proyectos, o sea, gracias al open source, tú inicias diferentes proyectos, y uno de los proyectos por los cuales yo te conozco es Wokwi, justamente, ¿no? El simulador de línea gratuito, ¿no? Y vienes con microcontroladores, IoT, que, para serte honesto, a mí me gustó muchísimo porque justamente encontré, por ejemplo, STM32, que no encontraba un simulador, entonces encontré uno, o SP32, me pareció mucho. ¿Cómo surge la idea de crear Wokwi?
Oh, that's a good question. If you look at the Wokwi blog and go to one of the very first posts, you will see that the original Wokwi was something else. It was, at that time, I was creating a lot of custom printed circuit boards from different projects. And I was kind of frustrated with the state of the software or the processes that you use to create open source or to create electronic boards. For instance, Arduino is open source, right? The board design.
Yes.
And if you want to have your own Arduino board, in theory you could, right? Because it's open source. But when I tried that in practice, it was very, very frustrating because you have the board design files, but if you want to make changes, like, I don't know, add a new sensor to the board, even if you want just to change the logo or, I don't know, add some text on it, there is a lot of work you need to do just to import it into the right tool and learn how to use the tool. And then after you make the changes, if it's like adding new stuff, then you need to maybe change the layout and understand what and how they did it, and then manufacturing it, like sourcing all the components and even like getting the PCB done and then PCB assembly. It's a lot of steps. Like, in theory, it's open source, but the open source I know from the web you write one command and you use it. Maybe you have to write a manual to know what functions are available, but basically you just pip install some package from Python and it's there for you. And with Arduino, you could also like buy the board, but if you wanted to make changes with Python, you just go to the source code and edit it, and that's it. And for Arduino, it's so complex. So the original Wokwi was just supposed to be a service where you have an online editor, you get an Arduino board, and you can make changes. Like you can add text, you can change the colors of the connectors, you can switch the bulky USB connector to USB Type-C. And eventually we wanted to support changes to the board itself. So adding new, let's say, neopixels or accelerometer. And I mean, it's a lot of steps if you have to do it yourself. But if we have like a pipeline of a supplier that does all the assembly, PCBA and like logistics, and we have like an interface that knows how to update the schematic when you add something new, and then maybe use some kind of AI for the layout, that shouldn't be very hard for the user to use. So that's how Wokwi started. And when it started, I asked myself, okay, we have the product, a prototype. How do we get users? So I started blogging about Arduino and stuff, and trying to get some traffic to the website. And then when I started creating Arduino tutorials, I was, okay, but I explain about blinking an LED using PWM on Arduino, but how do people get to try it? Do they have to get an Arduino board and plug it into the computer and connect the LED just so they can try it? And that got me thinking or searching for some kind of solution. And I think the only thing that was in market back then was Tinkercad. And Tinkercad was great, but it had two problems. First of all, it was not very easy to put it inside a blog or even to share projects. It was very good if you wanted to work on your own project, but sharing project was working so-so. And the more problematic part is that it was no longer being developed at that point. Like they stopped adding new features. I talked to one of the, so Tinkercad is developed by Autodesk, but it is a startup company that they acquired and developed it in-house. So I talked to one of the founders of the original startup company, and he told me that most of the team that worked on Tinkercad circuits already left Autodesk. So they don't have a lot of in-house engineering working on that. So at that point, I decided, okay, let's create an experiment. Let's try to create a quick simulation of Arduino from scratch in JavaScript, so I could use it on tutorials. And I spent a few days just trying to, like, I think a week, creating the first prototype that could run a simple Blink program. And at that point, it was just an experiment. I published a blog post with a link to this open source project and a demo of 2 LEDs and a code editor where you could change the code and click run and see the results. And some people were interested, but I think the turning point for Wokwi started when I published this into the Fast LED community. So Fast LED is a library that is very popular when people are trying to create animations with LEDs. And unfortunately, they did not have any emulator because Tinkercad did not support third-party libraries. They only have a limited set of libraries, so you couldn't use Fast LED on Tinkercad. And when I posted the simulator on like Fast LED, and I told them, hey, you can use Fast LED on Wokwi, there were a lot of people asking, hey, that's cool, I'm going to use this now. Can you add this feature? How do I pay to support you? Like, suddenly there was a lot of interest. And even today, some of the core community members of Wokwi are people who came from that old Reddit thread where I announced, hey, there is now a simulator that can do fast LED. So that's sort of how Wokwi came to be. This was like 3 years ago, but this is where we started.
Comenzó con la pandemia.
Yeah, more or less, yes. It started like a few months before the pandemic, but when the pandemic like started, I actually had like 5 or 3 or 10 PCBs, something between 5 and 10 PCBs that I was waiting to get back from China, and then nothing came back for a few months. So I had a lot of time to sit down and just work on the simulator, because I couldn't work on real hardware anyway. So that was my only option at the time.
¿Y ya has podido ver desarrollos o ejemplos de proyectos de la comunidad de Wokwi que han podido compartir contigo?
Like projects that people made using the simulation engine?
Yeah.
So, I think it was more in the early days. Nowadays, I don't know. People still make projects, but I guess the most interesting ones were the first ones that I saw. There was some guy from college in Canada, I think, that was creating a simulation environment for 2D robots to teach his students. So the students would write Arduino code to control the virtual robots, and they had like challenges. For instance, they had coins that they had to collect, and they had to read data from virtual sensors to navigate a maze with walls. So and collect coins. So I think that was one interesting development. There was also another guy who used the simulator to power his business. So he had like a business selling big LED matrices that you can hang on your wall, and instead of having to tinker with electronics, you could program them via Wi-Fi. He made an online interface where people could write Arduino code to control the animations on the LED matrix, and a community where people could share their code, and you could just grab a code that somebody made, hit send, and it would appear on the wall right behind you, the results. So that was another use case. And I think nowadays most people just use the simulator as is the online simulator, because it's so easy to use, and setting up your own environment with the compilation server and all of the backend stuff is like a lot of effort. So people just want to simulate. They don't want to spend a lot of time building their own simulators.
¿Ya tienes planeada algunas nuevas características que agregar para Wokwi?
Yeah, there is a list of things that people want to see and we are working on. I think the thing that I'm most excited about is 2 things. Custom chips, which means people can create new parts for Wokwi. You define what pins your part have, and then you write the logic in C, or you can also use Rust or Verilog. And you can basically extend the simulator in almost every way you can imagine. 2 very interesting things that people already did with that is somebody created an e-paper display. So previously we didn't have any kind of e-paper display, and somebody just spent a week and created an open source implementation of e-paper part for Wokwi. And the other one was very interesting use case. Somebody created a virtual oscilloscope.
Yeah.
We are providing you APIs to work with the GPIO pins, to talk, to speak SPI and I2C, and like to read analog pins. And there is also API if you are implementing a display where you can draw on a frame buffer, on a bitmap. So some clever person said, I have an API where I can interact with the digital and analog pins, an API where I can draw graphics. Why not make a digital a logic analyzer or scope? I think he made both. So that was really cool to see somebody actually extending the simulator and adding a scope without me having to do it. So custom chips is like, I think for me, one of the most exciting things that we are working on right now. Mi favorito. And then,
sí, acabo justo de ingresar a la página que tú me dijiste, Wokwi Fixtures. Y claro, hay diferentes opciones, ¿no? Que las personas pueden votar, ¿verdad? Pueden votar, pueden elegir cuál proyecto le gustaría comenzar, ¿verdad?
Sí. The problem is that there are so many ideas and people ask for all sort of things.
Yeah,
and it wasn't too long until I figured out I need some way to know what to work on next, like what people really want. Because at the beginning, I was just hear what people asked for, and usually I would implement whatever feature request was people was asking for in the loudest way. Like if somebody was messaging me every week, hey, is it ready yet? It would probably be ready much faster than somebody just asking politely.
Okay.
So I implemented this vote system. So I actually know what people really want, what's really important to people, and not just listen to the loudest person in the room. So that's a good way to see what's coming. So there is the custom chips. There is also like Wokwi for Visual Studio Code that is in development, and offline version of Wokwi that is just started working on that, but it's pretty high the list. And I think the second thing I'm most excited about is using Wokwi for CI, so automated testing. Instead of testing when you make changes to your code, testing them on real hardware, you could test them on Wokwi, but it's still manual. Like you have to run the simulation, press the buttons, see that the result you are getting is whatever you want to. And what we are working on is a way to automate that. So to create a file that tells Wokwi, now run the simulation, press this button, check the serial output and look for this string. Now set the sensor value, like if you have a photoresistor, set the amount of light to 1000 lux and check that this LED goes on. So basically a way to automate testing embedded firmwares. And imagine like having this run in CI. So whenever you make changes for the code, it runs automatically. And this is, by the way, something we do internally. So for the ESP32, we have the Wi-Fi simulation, and we already support like 5 or 6 different ESP32 chip variants. And there is like new releases of the ESP IDF, and we make changes to the simulator. So every now and then, some things in some of like new ESP IDF version and the specific chip, something breaks in the Wi-Fi simulation because it's like undocumented and it's very hacky implementation.
Yeah.
So we have this like automated metrics of tests that runs like 40 different combinations of ESP-IDF and chips, and it just runs a virtual access point, virtual station, and checks that the virtual station is able to use the virtual Wi-Fi to talk to the access point and get IP address. And we use this internally, and I think once per 2 months, it actually finds some kind of issue or regression. So we are able to fix those and to find those issues and fix them before customers even encounter them. Usually it's like some changes to the ESP-IDF that are in the very latest version, and it takes a few months until people upgrade to the latest version. So we know about those breakages early and can fix them. So internally, this has been very valuable, and now we are making it available for everyone. I hope other people can also find this useful. That's what I'm waiting to see.
Yeah, it's available. I really appreciate that, and they have a lot of things, and you are working hard. You have a team, or is only you working with the project?
A small team. Mi esposa and yo. Just the two of us. And yeah, it's a small family thing that we are working on.
Yes. Yeah, good. Para aquellas personas que tal vez quieren comenzar en Wokwi, ¿algún consejo que les podrías dar o recurso que tal vez deberían ver para comenzar con la aplicación, con el desarrollo?
Yeah, that's a good question. I think your video from 2 weeks ago is a good resource because it's Spanish and people watching here probably hablan español.
Yeah.
But I think it really depends. Like the first thing that somebody who wants to get started needs to decide is what are the goals. Some people just want to get a taste of embedded development, and then I would say go start with MicroPython. And some people want to turn this into a career. So maybe if they are just getting started, then Arduino is a good starting point, and then maybe evolving to Rust or to ESP-IDF. And there is like the documentation. Unfortunately, we don't have it in Spanish yet. We have in English, Portuguese, and German now, some of it. But maybe one of the listeners would find the time to translate it to Spanish. We had some user who translated everything into Portuguese, so now it's available for anyone speaking Portuguese. So I think the documentation is a good way to find yourself in Wokwi. Like if you know what you want to do, you want to use MicroPython and you know that already, then there is a document that tells you how to do this. Or you want to use the logic analyzer. But first of all, you have to know what you want to do. And we don't have any great resources for if you don't know what you want to do. But there are a lot of online tutorials, and there is your YouTube channel as well about how to get started with embedded development. So my suggestion to everybody asking me is always like, go and find a learning resource that fits your goals, and then use Wokwi as a tool to just speed your learning up. Or if you are already familiar with embedded development, then you probably have some goals in mind, and then you can check out the Wokwi documentation and see like what's the best way to get started. And we also have a very active Discord community. So you can go on Discord, and there are some users who are spending more time on Discord there than I do. So they usually answer questions faster than I do, but I'm also hanging there. So that's also a good resource if you if you want to get started and you are stuck and you need some recommendations.
Okay. Entonces, realmente yo igual la recomiendo Wokwi, me parece una buena herramienta que pueden utilizar, y es más, la estoy recomendando como viste en el video y más ahí comentando varios amigos. Pero ahora me gustaría hablar de otro proyecto que estás haciendo que es justamente open source, que es Tiny Tapeout, ¿no? ¿Nos podrías explicar para qué sirve, en qué consiste Tiny Tapeout?
Yeah, sure. So I'm also excited to talk about that as well. So Tiny
Me
Tapeout
too, me too.
is, um, in one sentence, it's making it possible for people like you and me to build their own physical custom chips. So in Wokwi, we're adding a way to create virtual chips, but as electronics engineers, we are sort of integrators. We can take existing off-the-shelf chips, put them on a PCB, make the connections, and create a product. But we never really get the possibility of creating our own chips. If there is, we want, I don't know, a RISC-V microprocessor with 5 cores and 3 timers and some kind of spatialized vector math hardware for AI or something like that. We just need to see if there is something off the shelf, and sometimes even combine different parts from different vendors to achieve what we are looking for.
Mm-hmm.
And this is like the reality for us. We don't know another reality. But there is a good reason for that. Producing our own chip requires a lot of expertise. It's expensive. The software is super expensive. So it's not like you or me are now going to throw $10,000
Yeah.
just trying to create our first chip and then failing because we don't know how to do that. And it's like super complicated.
Yeah.
So Tiny Tapeout is trying to solve this problem, to make it possible for everyone to create their first physical chip with a cost of about $100. So it's not super cheap like PCBs, but it's affordable.
Mm-hmm.
Behind the scenes, we are trying to be something like Oshpark, like the PCB service for chips for ASICs. We realize that most people, or when you want to manufacture a chip commercially, even for like proof of concept, you get a lot of space. Like it's a very tiny amount of space, like 10 square millimeters. But in terms of the number of transistors you can pack into that small amount of space, it's still a lot of space. Most people don't need to pack 100,000 transistors into their first design. Most people can do their first design with 1,000 or 2,000 transistors, and that would be complex and interesting enough for them to just, get the experience.
Mm-hmm.
When we realized that, we can like take a lot of people. Oh, and the second thing, you get tiny space, but a very expensive bit of space when you want to do this commercially. And you also get like hundreds of copies of the chip. But if you're just learning, you only need one copy and a small amount of space.
Yeah.
So basically, what we are doing, we are taking a lot of small designs, putting them together on one large design. Then we are commercially manufacturing a few hundred copies of that design, and then sending this chip with everyone's designs to everyone who participated. So that's how we are cutting this enormous cost into something that is affordable for ordinary people.
Mm-hmm.
And we are also like building software and tooling to make it easier for people to get started without like dealing with all the complexity up front, because the tools that you use to design chips, they have to, or they are trying to create the most optimized design possible. So they assume that you want to run at the highest clock frequency possible. They assume that you want your design to be as robust as possible and like work in different temperatures and different voltages. But for someone learning, that's not important. What they want to do is to create a design sometimes that has very simple logic, like traffic light controller or some kind of a state machine or game. And they don't really care if it runs at 1 kilohertz or 10 megahertz. They just want something. And the tools add a lot of complexity, and there are a lot of like different steps and options. So for people who are not really familiar with ASIC design and just want to get into it, we are trying to make it simple by just giving you automations that wrap those tools, so you don't have to fiddle with the configuration and find like the optimal settings. And I think that's an interesting like intersection between the two projects, because the easiest way to do something on Tiny Tapeout is actually using Wokwi.
Yeah.
When you looked at Wokwi, you probably saw that there are like logic gates in the parts that we have for your designs. So there is a way to use or Tiny Tapeout with Wokwi. You can actually create a diagram on Wokwi with logic gates and flip-flops. And there is a template on the tinytapeout.com homepage where you can start from. And you get like a block with input pins, a block with output pins, and a 7-segment display that is connected to the output, and a few switches that are connected to the input. And between those two blocks with the inputs and the outputs, you can put your logic, just any kind of logic using logic gates. And you can make whatever logic and then run it in Wokwi, see that you get a result. Like the default is using these switches and the 7-segment. So you can make some kind of game with the switches that has the result on the 7-segment. But we have seen people like just remove the 7-segment and add an LCD display and like create logic to drive the LCD display, or people who created some UART transmitter and connected it to an Arduino to test it all in Wokwi. And then once you get the logic in Wokwi and you are happy about it, there is a GitHub repository which you can clone. You can copy the link from the Wokwi project into the one of the configuration file, and that's it. The GitHub repo has a GitHub action that automatically downloads the diagram from Wokwi, converts it into Verilog, runs it through all the tooling that produces the final design file. That's a GDS file, the equivalent of a Gerber file for PCB. So that's a file you give to the factory and they know how to make it. And then once you have this, you just go to our website, put the link to your GitHub repo and pay, and that's it. You created your first digital design and it's going to be on a chip. So that's like the easy way. And then if you have more experience, instead of using Wokwi, you can actually write your own code in Verilog or other HDL and still use a GitHub action to automatically like go through all the steps and build a GDS file for submission. And we have like a lot of guides and tutorials on the website. So even for people who have no experience, they can learn how to do it. And there is also like a guide that explains how the transistors are made. So we released an open source tool called Siliwiz that lets you design your own transistors from like silicon and metal layers in the browser. And the sole purpose of this tool is just to teach people how these things are made. Because um, when you drag and drop logic gates in Wokwi, or when you write code in Verilog, you are describing the logic of the system that you want to build, right? But at the end of the day, um, there will be some transistors physically on the chip that will execute this logic. And we want people to understand like how those transistors work, like what's a PMOS, what's an NMOS, how you take two of those transistors and build an inverter. So this is like more of the educational side of Tiny Tapeout, where we teach you the basics of how digital design works at the transistor level.
Este proyecto tiene gran proyección, ¿no? Para hacer varias cosas, ¿no? La posibilidad de tal vez crear tu propio circuito, ¿no? Lo que alguna vez muchos lo soñé en la universidad, decían, no, me gustaría tener mi propio chip, pero costaba muchísimo y ahora hay la posibilidad más cerca, ¿no? Mi pregunta también sería, cuando yo tengo este proyecto listo, ¿tengo que esperar un tiempo, o sea, para que se envíen con varias personas, por lo que entiendo, o cómo es este desarrollo, ¿no?
So that's one of the other problems with ASICs and chips. It takes a long time. So the way we work, we have like 4 dates every year for deadlines.
Okay.
And you have to submit your design by the deadline. So the next one is in 6 weeks, 4th of November.
Mm-hmm.
4 in November.
Okay.
That's how we say it.
Yeah.
4th of November. And if you submit your design by that time, it will go to our next fabrication shuttle. So we hope that the chips made or the designs submitted in November will be available around May or June next year.
Mm.
And that's a bit optimistic because in the past, the first time we did it was last year, last September, and we only expect to get the chips back next month. So more than a year for the first time. We hope that we anticipate that the times will shrink to around 6 to 8 months, but this is a long wait also for us. Like imagine how long it is for us, and we want to see that it's working. We want to hold it in our hands, and but we are pretty confident that it will work because we work together with many people from the industry with a lot of experience who looked at how we put all the designs together, and they basically said that they believe it's going to work.
Mm-hmm.
And my partner for Tiny Tapeout, Matt, he also designed a few ASICs previously, and he got them back and they are working. And I did some test design and got it 2 months ago.
Mm-hmm.
And even though I had some bug in one of the designs, it largely worked. So we have past experience from our own designs that they work. So we are pretty positive that also the designs we get back are going to work.
Mm-hmm.
And we are spending this long wait times to improve our technical capabilities. So in the first runs of this service, there were very severe limitations. You could only run at, I think, 10 or 20 kilohertz. So it was very slow.
Mm-hmm. Yeah.
And we only had 8 input pins and 8 output pins per design. So it was very limited.
Okay.
And now we can run at 10 megahertz and even faster. And we have 8 extra bidirectional IO pins. So we are adding more and more capabilities as and you can also have like larger designs. Initially, we had to limit for like a single size, and now we support multiple sizes. So if you need more space, then you can buy more space, which was not possible previously. So we are internally upgrading like the architecture of the chip to support more features. So um, people can not only do just toy stuff just to get the experience, but they can also do actual stuff. Like we have seen people doing tiny FPGAs and RISC-V processors, and there was even some very innovative design where somebody designed a temperature sensor by exploiting, or yeah, I didn't even know it's possible, but apparently even with that just digital logic, uh, you can. I think he created a ring oscillator, so that's a circuit that just generates signal continuously, because it's just a loop of flip flops that are or inverters that are connected together, so they invert the signal continuously and oscillate.
Yeah.
So I think he used a ring oscillator, and the output varies with the temperature or something like that. So I'm actually, there is a video in Matt's YouTube that explains how this works. So I'm not very familiar with the details, but he did use some property that varies with the temperature, and then he measures this property in order to get a temperature. So you need to calibrate it, but once it's calibrated, it should be able to measure the temperature pretty accurately.
Okay.
So yeah, I didn't even know that was possible, but somebody proved that it was.
But maybe in the future I can make, for example, my own microcontroller. It will be a possibility.
But yes, please make your own. Yeah, we are seeing a lot of people making their own 8-bit microcontrollers, and some people are also trying to fit RISC-V into Tiny Tapeout.
Okay.
It's a bit challenging. It's possible, but you have to take out, or you have to be very conservative about the space. But it's possible. Some other interesting things we have seen: somebody implemented a USB controller in Tiny Tapeout. So when we get back the chips, you should be able to plug them to USB, and if you select their design, to talk with the chip by USB. There were a few designs that implemented VGA interface. So somebody created that nostalgic breakout game with a ball that jumps and it breaks bricks, and that's connecting to VGA. So you should be able to connect the chip to VGA, a few push buttons, and play the game. So and I think the most I would say shocking or awesome, or I don't know even the word, exceptional design we have seen is somebody who created Doom-like engine, like 3D maze engine that goes to VGA output, all of that on a small slot on the chip. So that's the one I'm really looking out to see, like in real action. People are doing really amazing things. You give them space, you give them the tools and creativeness. So yeah, please do create your own microcontroller.
It's amazing, it's incredible. Y alguien que quiere comenzar, alguien que quiere comenzar justamente a ver Tiny Tapeout, ¿por dónde debería comenzar? Entiendo que por Wokwi, que va a desarrollar simulaciones, pero ¿por dónde más podría ir también? Otra herramienta, recurso.
Yeah, there is the website tinytapeout.com, and unlike Wokwi, where it's the documentation is more like you know what you want to do, and we help you to achieve that. With Tiny Tapeout, we actually have like a very good videos that Matt made that show you step by step what you need to do if you want to start with either Wokwi or Verilog. So just going to the website, there is like a link on the left where it says digital design guide, and there is like a step-by-step guide to how to use Wokwi to create your first design. And there are like a few example projects with a walkthrough of how they explaining how they work. So you have like sort of course you can just go through and learn how to use Tiny Tapeout. And there is also like videos showing you how, once you made a design, how to submit it and to get it manufactured.
You mean a 0 to ASIC course?
So 0 to ASIC is actually Matt's, my partner's other project, which is for more advanced users. So
Okay.
The idea is, if you get started with Tiny Tapeout and you go through the Wokwi thing and you feel like you are ready to move to the next step, and you want to learn more about like the how to use the tooling yourself, not to use it through the GitHub actions, and about how to write very low code properly, how to do testing, formal verification. So basically work on a complex designs in a way that you will actually get the results you expect. Your microcontroller will actually be functional when you receive it. So that's where 0 to ASIC comes into play. So it's sort of like everything connects together. Wokwi is a great tool to get started with Tiny Tapeout. Then if you already know chip design, then you can just go straight to Tiny Tapeout and create your design and submit it. But if you want to get deeper into digital design and learn all the tools and best practices, then 0 to ASIC course can teach you that. So at the end of the 0 to ASIC, there is actually a chapter that talks about submitting the designs you made through the course to Tiny Tapeout. So it's all like connecting together.
Hey.
And by the way, 0 to ASIC was also how I started learning about chip design. Like that's how I met Matt, and we started working together through his course.
Oh, okay. We'll start. Entonces ya sabemos dónde.
I took the course and I can recommend it.
Ok. Tenemos ahí recomendación de Uri, que nos dice que tomemos el curso, que está muy bueno. Unas preguntas que me gustaría conocer. Leí en tu blog que hablaste sobre crowdfunding en hardware. No sé si me podrías decir o resumir un poquito la historia y contarme cómo fue todo el proceso de hacer justamente crowdfunding en hardware.
Okay, so I need to bring quickly a prop for that.
Okay.
So yeah, I'm back. So it all started a few years ago. I was invited to a conference, some small private conference here in Israel. And a few friends that were also participating in the conference, they contacted me and said, hey, you love electronics and we love electronics, and this is going to be a conference with tech people. So why won't we do a cool name badge for the conference, something with electronics? So I was dumb and I said, yes, let's do it. And so we spent the next like 7 or 8 months just iterating on hardware prototypes and doing all the mistakes that you can do when doing hardware, like using the wrong part numbers and whatnot. And at the end of the day, we had the actual badges. So you can see one of them is here. They have an e-paper. They have like this keys from a keyboard, so everybody could just choose their own keys for their badge. And they have this SAO, this expansion connector on top, and that's where the crowdfunding story will start in a second. So we had those ready just the night before the conference. I actually had to drive to the DHL office the night before the conference to get 2 boxes, and then we spent the entire night before the conference just unboxing them and programming them and yeah, as I said, we were stupid and we decided to take on this project, and we did all the possible mistakes. And one of the ideas that we had is to use this small expansion connector to create some sort of a riddle, a small add-on board that you could put into your badge, and this badge would run MicroPython or something like that. And you would use this, you would run code on this badge that would talk to this extension and try to extract some flag from it or make it blink. So some sort of capture the flag riddle. And obviously we only had those ready the night before the conference, so we didn't have time to do this. But after the conference finished, I actually went ahead and created those boards and created some riddle for them. And since it was no longer relevant for the conference, I just posted it on the Wokwi blog and open sourced like all of the riddle files and said, hey, if you want, I made like 20 of these. I'm selling them on Tindy. And if you want, you can also like take the instructions from the blog post and try it. And some people actually really liked the riddle, and they either bought it through Tindy, or some just made it. It was just an 80 tiny 85 and LED and a resistor, like very simple hardware setup. So some people just made their own copy and then went on to solving the riddle. So I figured out that I'm pretty good at making riddles with hardware, and that there is at least some type of people who are interested in that. And at that point, I had an idea. I don't know how the idea came to be, but an idea for another type of riddle, much more complex, with the same 80 tiny chip. And I was initially thinking of doing the same, like publishing a blog post with the riddle and then selling a few units on Tindy. But then I asked my life partner, mi esposa, I don't know, I was like worried. I didn't know how many units I should make, like 10, 50, how many should I manufacture? I didn't know if it will sell or not. And she told me, why won't you try crowdfunding? So that's how I got into crowdfunding. It was her idea, and I was just trying to figure out if I should make this and how many copies I should make. So let's jump forward a few, fast forward for now. This is the actual physical product that I sold in crowdfunding.
Yeah.
Just by looking into it, it's a skull with 2 LEDs. How do you say skull in Spanish, by the way? I don't think I know the word.
Calavera.
Calavera? You don't know it
cráneo,
either.
Cráneo,
Okay.
cráneo, perdón. Cráneo.
Oh, cranium, like the Latin words
Yeah.
used in when you study medicine, you use cranium.
Yeah.
So yeah, so I know this word. I didn't know it was in Spanish. So this cranium, it has 2 LEDs for eyes, and then on the back of it, it has like this grill. That's how when you touch it, the eyes activates.
Mm-hmm.
Just a resistive touch input, and an 80 tiny 85. And it looks like a simple gadget, right? One input button to output LEDs and some microcontroller. But inside this microcontroller, there is actually 2 things. There is a secret that you need to extract. So a few words of text that you need to find a way to get from this chip. And there is also, I call it Spell. It's a secret programming language. If you go to the homepage of this skullctf.com, but instead of, I think the text is reversed here, but it says skullctf.com, skullctf.com/spell, you can actually see the source code of the virtual machine that runs this, or the interpreter that runs this secret language.
Mm-hmm.
And so the riddle is, first of all, you need to find a way to make the skull blink just one of the eyes instead of blinking both of them. And then when you find it, you need to somehow trick it into telling you what the secret is. And then you need to find a way to program it to do new things, like instead of blinking the eyes, fading them slowly on and off. And then there is another secret that is hidden. So it's like a set of riddles that you can do with this innocent cranium.
Yeah.
Cranium. And cranium, yeah. It's like you need to know a lot about you need to spend a lot of time with the 80 tiny datasheet to actually solve this.
Mm-hmm.
And I don't want to spoil it, but there is also one restriction that is pretty surprising for people who find it for the first time. You are supposed to solve this without making any electrical connection to the chip. So no electronics or no direct connection to the skull, only through this interface of this button and the eyes, but only make connections with your hand, not with any electronics to the button. So that's when I started my first. It's quite interesting when you find out what's the mechanism to this. And this is like the what I tried to do in the crowdfunding, and it was pretty challenging. There is the blog post you mentioned. There is like a lot of steps in setting up a crowdfunding campaign. I didn't realize it until I did it.
I read all.
You do?
Yeah.
Wow, it's like I think 20 minutes to read it.
It's a long story,
It's
but
crazy.
it's crazy. It's a good story.
Thank you. And it has like a lot of links to all like the drafts of the text that I wrote for like the campaign and how Crowd Supply, the company who run the campaign, how they improve them, and all of the things that I tried to do in order to make it more interesting that didn't really change at the end. I think it was a very unique experience for me to run this campaign, and it didn't bring a lot of money at the end of the day. I think it was a bit more than $1,000, like the revenues, and that's like before taking into account all the costs I had for like doing the prototyping and all the time spent on it. I think one of the more interesting anecdotes about this, and I don't think I ever told this, or maybe I did just briefly mention it. Developing the firmware for the riddle was a big challenge because I really needed it to be perfect on the first attempt. If I had to tell people to upload a new version of the firmware, theoretically, there is like this connector here when you can connect an ICSB programmer. But if you try to reprogram the 80 tiny, that would override the flag, the secret code. Obviously, I published the firmware, but I didn't publish the secret code. It was just in a very specific build that I sent to the factory to fabricate those.
Mm-hmm.
So basically, if the firmware wasn't good enough and people had to update it, it would ruin some of the riddle. They couldn't, like they would have to erase the chip first and lose the secret flag. So I had to get the firmware perfect. And without spoiling too much, I would say that I had to test this firmware in many different lighting conditions. And doing those tests manually took like half a day. Every time I made a change to the firmware and I wanted to like check if it impacted how the riddle is solved and if it made it easier or harder to solve the riddle, I would have to spend like half a day just, manually testing something like 40 different scenarios. And at some point, I realized it was never going to be ready on time, because making a change and then spending half a day just testing it wasn't allowing me to iterate at all. I would make a change and then I would be frustrated that I have to spend half a day testing it. So I would postpone it for a week or two, and then it wouldn't work. So I would get more frustrated. So eventually what I did, I spent a week with a logic analyzer, just recording a lot of data from the testing environment under different conditions. So I had some kind of data set of like different environmental conditions that I knew that I wanted to be able to solve the riddle, and another data set of like things that shouldn't solve the riddle. And what I did, I used the simulation engine of Wokwi to create an environment. Whenever I made a change to the firmware, as soon as I saved the file, it recompiled the firmware, and then it used those data sets to run something like 40 different test scenarios and give me like score of how well these changes affected the result. So suddenly, instead of waiting half a day of boring manual tests, I had a system where I could run all the tests in simulation in like 5 seconds. Imagine like I actually set for 1 day and did a lot of like different iterations until I found the right combinations of parameters that I needed for the firmware to function as good as I could in all the different environment settings. And then like I can't imagine how I would complete a firmware if I didn't have this setup of like just getting instant feedback on changes to the firmware. So I think that was one of the more interesting challenges, technical challenges that I never told anyone about. That and the fact that I wasted 2 weeks because the 2 weeks because of the logic analyzer connection. Like I used long wires that ran in parallel, and they would introduce some noise into the analog signal. And it took me 2 weeks to figure out that the source of the noise was just running like all those logic analyzer cables from the back of the cranium into and that they picked up noise. So I spent 2 weeks trying to figure out why the data didn't make sense. And then, wait, I just created an antenna there and I'm running digital signals next to the analog signals. Maybe that's the reason I'm seeing like spikes in the analog signals whenever there is like changes in the digital signals. I guess most of the people who are working for years in the field, they wouldn't do this stupid thing, but that's how you learn, right? You make stupid mistakes and then spend 2 weeks trying to figure out why you get noise.
A lot of hard work, for making this.
Yeah, it was like, I think half of the hard work was, or 2/3 of the work was on the crowdfunding campaign, and then like writing all the text and making the updates whenever we sent weekly updates about the progress, and we wanted to make them interesting. So instead of like telling people, we are working on the project, but we can't tell you anything about the progress because then it would ruin the riddle. I just wrote stories about how we went to the deepest, to the Amazon forest to summon a shaman that would bless the firmware, and then he gave us like some coordinates, and we went to they were in the ocean, and we went to the ocean, and we found there 2 scrolls with pieces of code that would fit into the firmware, and like all these fictional stories that I hope kept the people amused while they were waiting for like the campaign to finish and for the actual hardware to be ready.
Mm-hmm.
And then the other part of the time, or the hard work, was figuring out the logistics, just getting this 200 pieces of this manufactured. I don't know how many people would anticipate what was the biggest problem. The biggest problem was this battery. We said in the campaign that this is going to be with batteries included.
Oh, okay.
And manufacturing the board wasn't a problem, but finding a PCBA company that would handle shipping with batteries, that was a nightmare. Like, I went to every single Chinese PCB assembly vendor that I knew,
Mm-hmm.
and they were all saying like, yeah, we can make it for you, but we don't ship with batteries. If you want to ship with batteries, then you need to figure it out. And eventually I found some vendor that I haven't worked with before that said, yeah, we will do the batteries, no worries. But I didn't really know them. So it was sort of a bet whether they will be able to actually create a quality product and pull it out in time. And there were like Chinese holidays approaching. And like, I don't like logistics.
Yeah.
I think that's one of the main reasons that I'm now doing simulation, or at least for some time I was just only doing simulation, because I don't like logistics, and anything that has to do with hardware involves a lot of logistics, headaches, and supply chain. And
yeah. It's a good point.
Yeah, that's the story of the skull.
Yeah, story of skull. It's good story.
Cranium.
Yeah. I really recommend to read the blog post I'm going to share also. They can find. It's a good story. I think it's a good story. Tengo algunas preguntas curiosas como para ir terminando. Una de ellas es que me cuentes The Salsa Beat Machine. Yo lo encontré en tu repositorio. Pude ver algunos, probar tanto en salsa, merengue, y de verdad sonó muy bien. Y
1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4.
La verdad que no sé cómo se usa, pero interpreté o entendí que no, era cambiando la configuración, cambiando la condición de la guitarra o el instrumento, ¿no? Cambiando diferentes usos hasta las notas musicales, y ahí pude obtener. Entonces me gustó cómo sonaba, iba cambiando, encendía, apagaba para ver cómo creaba música, pero cuéntame un poquito, ¿cómo es esto de Salsa Beat Machine?
Sí, todo empezó cuando yo quise bailar salsa. Y cuando empecé a aprender cómo bailar la salsa, tuve un problema mayor. No tenía ninguna idea de ritmo.
It's a big problem.
Fue como hay pasos y sí, yo aprendí los pasos, y like sabía cómo mover mis piernas y cómo hacer todos los movimientos. Pero tenía un problema que no entendí cómo eso conecta con la música, cómo encontrar el ritmo en la música, cómo dónde está el uno. Todo el mundo hablaba, tienes que bailar sobre el uno, en el ritmo. Y yo no encontré el uno, no sabía dónde está.
Where is it?
Lo que pasó es que yo realizaba que tenía que aprender cómo funciona la música. Es como soy un ingeniero, yo quiero analizar things y aprender cómo funcionan. Entonces, tratado de aprender cómo funciona la música y what I found out is that there are it's complex.
Yeah.
There are many rhythms and there are many different types of instruments.
Yeah.
And I think the first time I actually found a rhythm in the music was when one friend of mine just took my hands and started dancing with me. And then it clicked for me for the first time. I could find the connections between, my brain could make the connection between the music and the movements that I was doing. And it was sort of magical. Hey, this is like what everybody is talking about. It's real.
It's real.
Hay uno, hay ritmo. It's not just it's not like just something imaginary that somebody else, that everybody else experienced and I don't. And then I realized that I was still having a lot of issues with, I could hear the basic pattern of the rhythm, but keeping up in the keeping the timing correct and anticipating how the music is going to change was still a big challenge for me. And also I had a different challenge where I didn't understand what they were singing about. There is a song from Mark Anthony called Contra la Corriente.
Mm-hmm.
And in that song is saying, yo trato, pero no te olvido.
Yeah.
And I thought that he was saying, so I heard that song and I thought he was saying toda, toda, toda. And in my language, Hebrew, toda means thank you, gracias. So I had a friend who spoke a little bit of Spanish and I asked him, who does Mark Anthony thank to? ¿A quién agradece Mark Anthony tanto? And he explained to me, no, he doesn't thank anybody. Yeah. It's a song about how hard is falling in love with something and resisting it is like swimming against the current. And I'm like, so there is not only rhythm in music, there is also words, lyrics. And that's why I started learning Spanish. I think my first few years learning Spanish were just me translating salsa songs painstakingly using the dictionary word by word to understand their meaning. And I remember a few sentences for some from some songs one of the songs from Hector Lavoe.
Periódico de ayer.
I will probably remember which one in a moment, but he has a sentence, a tu casa yo no voy polito, dame y tumba la chaveta.
Okay.
And I'm like, how do I translate it? What does it mean there? So there are a lot of songs with some very colloquial terms, very specific slang that I couldn't understand. And I still remember it today because I spent so much time trying to understand the engineer in me, try to reverse engineer it and understand what I mean. So it was learning Spanish and learning about the music at the same time. But I figured out that the best way to learn the music was to break it down to different parts. So that's how the salsa beat machine came to be. I read a book about Latin music and how the piano works and how the bass works. But, reading about this doesn't really teach your brain how to listen to it. So I started like coding something that would play just the piano, something that would play just the bass, and then running those programs together. And at some point, I created a user interface because it was becoming too hard to control it using initially I had some like Python script with text interface with keyboard shortcut. And then I decided to share it, and there was a lot of interest. It's not something that I'm working on today. Like if you check the GitHub, there is no activity there, but I know it's still being used in a lot of salsa schools around the world. And every now and then I'm getting an email from some users that tell me, hi, it helped me so much to learn how salsa music works. So basically this is why and how I started working on the salsa beat machine. And this is also how I met mi esposa dancing salsa, bailando.
Eso es bueno. La música unen, podríamos decir. Genial.
De acuerdo.
De acuerdo. Yo lo he probado en web, no también en App Store, en app, pero me ha gustado porque también he estado jugando, como te mencioné, ¿no? Y le he compartido a algunos amigos, a ver qué tal. Si le gusta. Todavía no me han dicho los comentarios, pero ya te contaré. Genial.
Gracias.
¿Qué área te gustaría aprender que no has aprendido aún?
So every year or so, I try to take at least 1 month to do something new or learn something new. So in 2 years ago, that was like the chip design. So I took a month of working Wokwi. I just spent the whole month. The first week I took Mats, my partner, back. I just met him back then. So I took his course. It's an online course 0 to A6, so you can do it at your own pace. So I'm like, my own pace, that's the maximum speed. So I spent a week just doing it and nothing else. And then I spent 3 weeks just practicing designing 3 types of chips. One of them actually connects to the story about the skull because it was hardware implementation of this hidden programming language that we had in the skull riddle. So I spent a month just taking the course and designing my own first chips and sending them to manufacturing. That's one example. Another example, I think I mentioned it in the beginning, is just before the pandemics, I spent like 3 months doing nothing but learning about microbiology, how our body works, how the cell works, how genetic works, all of the like developments in this area, like gene editing with CRISPR, and like I gained the ability to like read papers in biology and actually understand them, whereas before it looked like so unfamiliar and foreign. I would look at a paper and I would say, it's a piece of like there is text and words, but I don't understand what they mean together. So now I do. This year I spent a month doing something pretty weird, reading a book. There is a book published a few years ago. It's not a book. It's called a web serial. It's like a blog post where they post a new chapter of the book every week, or in that case, they posted 2 chapters per week. And that went for 2 years. So it turned out being something like 7,000 pages of a book. It's science fiction. It's pretty hardcore science fiction. And I just started reading it. And for a month, I did more or less nothing than just read this very, very long web serial, which I don't know if it taught me anything new, but it was entertaining.
Yeah.
So, yeah, I honestly don't know. Every time, sometimes something sparks my interest, and then I just stop everything and learn how to do it.
Yeah. Is it good?
That's a good question. If the listeners have some suggestions, what it would be next time?
¿Podrían darme 3 consejos para las personas que quieren crear cosas así como tú, o tanto en open source o en hardware, por ejemplo, en crowdfunding? 3 como que palabras o consejos que les podrían dar a ellos.
That's a good question. I think the most important thing is try to relax. Like, we have a lot of preconceptions about how things should be done. Like, if you are doing crowdfunding, then there are a lot of ideas about what your goals should be and how it should work. And in reality, things don't always go, or usually they don't go according to plan. Yeah. And most people, when things don't go according to plan, they get stressed and they are like, oh my God, we have like 2 weeks until the end of the campaign and we are not going to eat the coal. We are so going to try everything. And I realized that this kind of attitude just leaves you tired. It burns you out and it takes the fun out of doing things. So nowadays I'm trying to, when I work on projects, I try to take it slowly, to plan for the longer term and not think about hitting short-term goals, because there is always going to be some short-term goal. Most of the goals are arbitrary, and they are either set by your, I don't know, if you are working for a startup company, then they are set by your investors or your board, or in most cases, you set your goals. And if you set your goals and you are trying to hit them, and you are hitting them without a lot of effort, that's amazing. But in most cases, you set goals that are high and it's hard to hit them. And then if you don't hit them and you start to get stressed about it and you are like acting desperately in order to try to meet the next goal, relajar, that's like me. I think the most important thing that I learned, like, most of the deadlines are artificial, or the goals are artificial. It's either you or other people who set them. And if you set them, then you can change them. Or if other people set them, then you can talk to them and explain to them why it makes sense to change them instead of like blindly chasing goals all the time. And it's important to always take a step back and look at the bigger picture. Like, if we think it would be, for Tiny Tapeout, if we think it would be good to have like, so we are selling space on the chip, we're selling slots on the chip. And if we think it's a good goal for us to fill the chip, then that's great. But if we are 5 days before the deadline and this chip hasn't been filled, we can panic and start like throwing around ideas and talking to everybody and trying to make every single sale we could. But we can also take a step back, relax, understand that this is a part of a bigger plan, and 5 more sales or 10 more sales before the current deadline are not going to move the needle. They're not really going to change anything in the grand scheme of things. So I think for me that making that kind of realizations is the most important part. And for the crowdfunding campaign, it was successful, but it also taught me that it's not what I want to do. Like, I thought it would be cool to have some kind of hardware product, and I enjoyed most part of working on it, apart from the logistics. But after I did it, I realized that it's not what I want to keep doing. So it's also okay to, not define yourself as I'm a hardware maker, or I'm a salsa dancer, or I'm I don't know, Tiny Tapeout or anything like that. You work on stuff that interests you, and it's okay to eventually decide that you want to do something else and move on. Otherwise, if I know a few people who, from the time that I danced salsa, where salsa was their identity. If you looked on their social profiles, their name was just Joan Salsa. That was their name, like last name Salsa. Everybody knew them as Joan Salsa. That was their identity. And I think it's important to be able to take a step back and ask, the fact that I was interested in salsa 10 years ago, is it still interesting for me? Is it still part of the identity? So I think if I look at myself, todavía hablo español. So that's one thing I took from salsa. I still listen to a lot of Latin music and I enjoy it. That's another thing I took from salsa. Mi esposa, another benefit of salsa. I've made quite a few friends. Some of them are still friends to date. But I don't really dance anymore. I get to dance once a year, and that's okay. Like, I did it in the past. And in the past, I was like doing salsa full time. And now it's just a small part of my life. But a lot of things have remained with me from that time. And the fact that I'm no longer working on the salsa beat machine or spending time dancing salsa, because that used to interest me in the past. And now it opens up a lot of space for new things, like working on Wokwi or Tiny Tapeout. Or there was a dozen of other projects that I worked on before Wokwi and Tiny Tapeout. And even with making, during the pandemics, I stopped making like physical stuff, stopped working on PCBs and stopped like building robots and almost stopped 3D printing. And that opened up a lot of space for working on Wokwi and eventually meeting Matt and moving to the chips. So now I still occasionally make stuff, but it's not like I'm limited to do it. I used to do it like full time and spend days working on badges and hardware, and now I'm no longer doing it. But from time to time, when I need it, I have the tools that are available, and I think that's the second thing. Like, the first thing is relax, and the second thing is it's great to try things, and it's great to learn new things, but it's also good to move on to try new things. Just like you asked me, like, what's the next thing you are going to, or you want to learn? And the answer is, I don't know. But when that thing comes, I know that I will be able to make the time to learn it like I did before. So I know there will be a next thing, and I know I will have time for it. When it comes, we'll find out what that thing is. And yeah, I think that was two, but that's all I have now.
Yeah, good. Thank you so much.
Oh, the third one, be friends with Wels. He knows a lot.
Yeah, make friends. De verdad, muchísimas gracias. Thank you so much for the time, for being here, for speak English and Spanish. Thank you so much, and share all Tiny Tape-Up, Wokwi, everything. Thank you so much. When or where we can find more about you?
Yeah, so I think I mentioned it. So Discord is where I'm very active nowadays. So there is Discord for Wokwi or Tiny Tapeout. And I used to be active on Twitter, now not so much. So a little bit, maybe I will be moving to LinkedIn. Right now I'm mostly spending my time building stuff. So I think the best way to actually catch up with me is those kind of interviews. So I'm doing an interview every once in a while. last time I did with Robert, who is also has a YouTube channel on electronics and PCB design. So every few months I'm going on a podcast or YouTube like this. So probably the best way to keep up to date with me. There is also my website where I used to blog a lot. Nowadays, I don't blog so often. Maybe I will get back to it at some point.
Okay. You mentioned Robert, what's his name? Fernandez?
Yeah, something like that. Fernek. I never remember his last name. So I didn't want to say it wrong. But yeah, that guy.
Okay, that guy.
Yeah.
I know who is that. only
That's
for
Robert.
Yeah, Robert, yeah.
It was really fun interviewing with him. I really enjoyed he's really a good interviewer. You're too.
Okay, thank you so much.
You're actually my first interview in Spanglish.
Yeah, it's the first time, so it's difficult, but I enjoy it also. Good to start with a community in English. I think that we can change different opportunity to. We have project in Spanish and also in English, so it's a good start. Well, thank you so much. De verdad, muchísimas gracias por tu tiempo nuevamente, por contarme muchas historias. Y ya saben, en la descripción voy a dejar los blogs, los enlaces de todo para que puedan revisarlo. De verdad, se los recomiendo muchísimo porque están muy buenos. Los he podido leer un montón, tiene un montón de información. Y vayan por Salsa Beat Machine, que está muy bueno. Se lo recomiendo. Yo me entretuve un ratito. Está muy, muy interesante. Nuevamente, gracias, Uri. Muchas gracias. Y nos vemos en el siguiente episodio. No te olvides suscribirte, darle like y compartirlo con tus amigos. Chao, chao.
Gracias y hasta la próxima.
Muchas gracias por escuchar este episodio. Nos vemos la próxima semana. ¡Suscríbete!